Hey, geometry, we're back. We're on question 8 for day 136 and 137, so let's get back to it. A quadrilateral has diagonals that are not congruent and are perpendicular bisectors of each other. Therefore, the quadrilateral must be... Okay, so this one was very, very, very wordy. So, diagonals that are not congruent. I want to first eliminate the ones on the here in which the diagonals have to be congruent. So, by one of its characteristics, a rectangle we proved in chapter 6 has to have congruent diagonals. We also, whenever you prove something is true for a rectangle, then you've instantly proved it's true for a square, because a square is a rectangle. Okay, so now we have 3 figures in which I could easily draw a version of them in which the diagonals are not congruent. So now we're gonna crank it up a notch. We're gonna say perpendicular bisectors must describe the remaining ones. So, does a trapezoid always have a perpendicular bisector? No. I mean, I could easily draw one where it'd be hard to convince you guys that, well, it maybe looks like it might be at a 90-degree angle, right? But that's only if these two are the same and these two are the same. That's what a kite would be. So trapezoids do not have perpendicular bisectors. A regular parallelogram? Again, I need to make sure I don't draw a rhombus or a kite because they actually have perpendicular bisectors. All right, so here's what I'm going to do. The rhombus. The rhombus is the one, just kind of by its defining characteristics, has perpendicular bisectors. So you know how back in the day we went through the whole list of descriptions for each one? Make sure you have that handy when you work through this assignment. So letter number 8 is B. I'm sorry, D. Okay. Wow, the start of this is not going well. We're going to recover though. Number 9. Which quadrilateral does not always have perpendicular bisectors? So we have just been talking about those, so we're good. Perpendicular bisectors. Kites have them. Rhombuses or rhombi, they have them. And a square technically is a rhombus because a rhombus is a 4-sided figure where all 4 sides are congruent. And that's what a square is. A square has all 4 sides congruent. So which quadrilateral does not always have perpendicular diagonals? Well, then it must be the isosceles trapezoid, right? Well, wrong. If we can prove that they intersect at perpendicular bisectors. This is what an isosceles trapezoid looks like. What do you guys think? Does this look like a 90-degree angle to you? It is not. So that is the one that does not have perpendicular diagonals. Letter D. All right, and here's our last one. This last one is the wordiest of all these multiple choice questions. It's not a nice one. I'm kind of sorry I put it on the test originally. But it really makes us think. 2 consecutive angles of a trapezoid are right angles. So I'm just going to stop right there. Let's get a marker with a little more ink in it. And let me write what that looks like. Let me draw that out. So here is a trapezoid. With 2 consecutive angles that are right angles, okay? But it could also be this, or it could look kind of like that, or it could like form in this shape. I'm purposely staying away from like normal looking trapezoids, so let's check this. 3 of the following statements about the trapezoid could be true. Which statement cannot be true? So they're really making us ponder this. So the 2 right angles are base angles. I found one. Those would be considered base angles. So this one could be true. Which cannot be true? So A, out of the question. B, the diagonals are not congruent. Well, we just talked about in a previous setting how the diagonals of an or maybe I didn't say it. The diagonals of an isosceles triangle are congruent. That's the only type of trapezoid that has congruent diagonals. These can't be isosceles. They cannot be isosceles trapezoids, all right? Because their opposite sides here cannot equal one another. Okay? And it's not the sides that are parallel. Because if you start doing that, then you're starting to like create the definition of a parallelogram. So this is sort of like a not situation. The diagonals are not congruent. Correct, 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 correct. So that's a true statement. 2 of the sides are congruent. Well, let's see if I can draw that. So let's say this side is exactly 2 inches. This side is also exactly 2 inches. All right, we're struggling here. Aha. So, these 2 are the same. And then you're left with something like this. Now, it's not a kite because this side is definitely not the same measurement as this other side here. And I suppose these are 90 degrees. This could be true. I could draw 2 consecutive angles of a trapezoid that are right angles in which 2 of the sides are congruent. Just drew it right there. And then letter D, no 2 sides are congruent, is basically trying to contradict the statement I just checked off the list as, yeah, that could happen. So, if this is the opposite of that, then that makes it true. It means, which statement cannot be true? It cannot be true that there are no 2 sides that are congruent, because I just showed a situation where 2 sides are congruent. It's letter D. All right, let's get out of the multiple choice, okay? I'm actually going to skip number 11 and come back to it at the end, because I think this can get very, very heavy, and I want to see some of the calculation algebra-related ones, so you guys don't get too fatigued by this. Because this is a lot, guys, okay? This chapter 6 was a whole chapter, right? Okay, so applications of quadrilaterals. All right, so for our first one, it basically gives us, hopefully you guys can see that on the video. If not, check out the notes. We've got I guess I should say that these are all parallelograms, So then you can use all the rules of parallelograms. My bad on the directions there. Now parallelograms state that opposite angles are congruent. So we know that y plus 10, which is this angle right here, is equal to angle 2y minus 40. That's just angle A is congruent to angle C. So you can set them equal to each other and solve for y. Which, at this point, solving equations is pretty basic and easy for most of us. Get the y's over to the right, move the 40 to the left. Y equals 50. Now the second part of this angle right here is 4x. Okay? That's where people start to guess sometimes if they don't know how parallelograms work. But we know that consecutive angles inside of a parallelogram, they're not congruent necessarily, they're supplementary. So y plus 10 plus 4x is 180 degrees. Furthermore, we know that y equals 50. So I can take that y out of there and plug in 50. Which leaves us with a pretty simple equation that I think everybody there can solve. So 60 take the 60 to the other side. 4x equals 120. Divide by 4, divide by 4. X equals 30. All right. Y equals 50, x equals 30. And I'll tell you, most people get this first part right off the bat. It's remembering that consecutive angles in a parallelogram are supplementary, that they add up to 180 degrees. That's what a lot of people forget. All right, so that does a good job of displaying some things for the angles. Now, what about if we're given only sides? Well, these are all 90-degree angles, so we know we got a rectangle. So does that help us any better with a quadrilateral? Not necessarily, because we know they're parallelograms, because I said they were at the beginning. I should have put parallelogram right there. Opposite sides of a parallelogram are congruent. So 3f plus 2 is equal to 5f minus 8. Over here, g plus 6 is equal to 2g minus 5, because opposite sides are congruent. They're not necessarily all congruent to one another, though. Don't assume that. Just because you got 4 90-degree angles does not mean it has to be a square. It could be a rectangle, which means that all of the sides are not the same. So use your basic understanding of solving equations. I got the f's to the right, the constants to the left, and I'm left with pretty solid answer. F is equal to 5. Over here, subtract the g, add the 5. 11 is equal to, I just put a 1 in front there, so it's 1g. It's just g. G equals 11. I'm running out of time in this video, so I'm going to stop it and start a new one. It'll be just a regular continuation.